Yeah, dear student, good morning. In last video, I defined angular velocity and average angular velocity omega average was given as delta theta upon delta t. Delta theta upon where delta is the angular displacement in time interval delta t. Here in figure body going from A to B in time interval delta t. What is delta S? Length of arc. Now, if delta t tends to 0, means it is small, then average angular velocity becomes instantaneous velocity. Then V omega average equal to instantaneous angular velocity, and that is V omega is equal to limit delta theta upon delta t or omega is equal to d theta upon dt. When dt becomes small, the length of arc becomes small, and hence if delta t tends to 0, then delta S is written as equal to ds, and d theta is equal to r upon radius, indicate ds upon r. Therefore, omega is equal to 1 upon r into ds upon dt. ds upon dt, and hence we write omega equal to v by r, or v equal to r omega in simple sense. Magnitude of linear velocity will be equal to product of radius and angular velocity at that time. Here this v is the magnitude of instantaneous velocity. Here I told you when delta t tends to 0, delta s becomes ds, and ds means this is simple length, small length, and ds here the arc becomes tangent. At delta t tending to 0, ds will be like tangent, and therefore linear velocity at every stand when body moves on circular path, is along tangent. So linear velocity of a body moving on circular path has magnitude v equal to r omega and direction along tangent at every point. If it is here, it will be like this. Okay. Actually, I have seen no book explain why linear velocity along tangent. If delta theta becomes delta t tends to 0, then delta theta also tends to 0, and when it tends to 0, the arc becomes tangent. A tangent is perpendicular radius, and therefore linear velocity always has act along tangent. This is very important. Now you know, yesterday in this last video I told omega is omega means angular velocity a vector quantity, and I told you body move anti-clockwise, omega in radially outward. The position vector R has direction O to A. Vector R direction O to A positive. है भाई? So if body moves on circular path here, then angular velocity is normal to the plane movement outward like this, but we show it like this. And this is position vector R. Velocity is this. Listen to me. If it is the circular path, angular velocity vertically up, radius this way, velocity this way. So we can write vector relation between V and R, omega. That is V equal to, I mean, omega this way, cross product R this way, velocity this way. तो R cross omega करेंगे तो V दस आएगा. तो it is R cross omega. Because angular velocity vector, position vector is a vector, and omega is also vector. Direction omega is normal to plane of circle. Velocity in the plane of circle. Radius in the plane of circle. Listen to me carefully what I am telling. The body rotating like this, anti-clockwise. So omega is vertically upward. Radius radially outward, velocity this way. So velocity along tangent and in the plane of circle, omega like this. तो R क्रॉस ओमेगा करेंगे, अगर यहाँ बैठ के मैं उधर देखेंगे आप तो आएगा अंदर की ओर. ठीक है भाई? तो इट इज R क्रॉस ओमेगा, रिलेशन बिटवीन लीनियर वेलोसिटी एंड एंगुलर वेलोसिटी. तो आई थिंक इट इज वेरी क्लियर टू यू कि व्हाट द रिलेशन बिटवीन लीनियर वेलोसिटी एंड उल्टा लिख दिया यार. आई डाउट. सॉरी. R is this way. R is in the plane of circle. Velocity in the plane of circle. Omega upward. तो ओमेगा क्रॉस R करेंगे तो क्या आएगा? सॉरी क्लोज हो गया. सो V इक्वल टू ओमेगा क्रॉस R. सॉरी, प्लीज करेक्ट इट. Velocity V in vector form is related with omega and R. R क्या है? Position vector of the spine. It has direction always outward. So you may be asked, magnitude of velocity V equal to R omega. है भाई? Magnitude. For example, if there is a flywheel of radius 10 centimeter and its rate of rotation is 120 revolution per minute, then find the linear velocity of body on its circumference. So first you find omega 2 pi n, n equal to 2 pi into n. ये per minute है, we convert into second and divide by 60. So 2 is 4 pi. And V equal to R omega, R 10 7.10, or into omega this 4 pi. So it is 0.04 pi. Pi equal to 3.14. This meter per second will come out what? Linear velocity. You have seen when this body rotates, suppose it is any body rotating about this axis with omega, then every particle will have same angular velocity, but different particles have different linear velocities. Farther the particle from axis rotation, greater the linear velocity, while angular velocity of this and the same. Wherever the particle is there, if body rotating on circular path, any big body rotating fan rotating, every point on the blade of a fan have same angular velocity but different linear velocity. V equal to r omega. Now there is one more term here, angular acceleration. I want to define here itself. Angular acceleration. Angular acceleration. I told you while teaching acceleration, in motion there is acceleration if velocity is increasing or decreasing. Means when velocity of body changes, there is acceleration. So if a body moves on circular path and with variable velocity, at time t1, angular velocity omega 1 here, and at this point at t2, omega 2, sorry, omega 2 here. After time interval, here t at time t1, it is at time t2. Then angular acceleration. Angular acceleration. Alpha, I write alpha. Omega 2 minus omega 1 upon t2 minus t1. This is in one sense average acceleration. Is equal to delta omega upon delta t. But if delta t tends to 0, if delta t tends to 0, then alpha is equal to instantaneous acceleration, angular acceleration, will become d omega upon dt. I don't want to go in detail. Alpha, d omega upon dt, but you know omega equal to d theta upon dt. So alpha can be as d upon dt of d theta upon dt equal to d2 theta upon dt square. Unit of alpha, unit of angular acceleration is radian per second square. It is also a vector quantity. Angular acceleration is also a vector quantity, and it will be along the change velocity, direction of angular acceleration. Angular acceleration will be along omega 2 minus omega 1. So, if a body is moving with increasing angular velocity, suppose anti-clockwise here, then alpha will also be normal to plane movement outward. But if velocity decreases, omega 2 less than omega 1, so direction will be opposite to the linear angular motion. It will be into. Remember, acceleration, direction of angular acceleration is along omega 2 minus omega 1. If body moving anti-clockwise with increasing angular velocity, then direction of angular acceleration will be normal to plane of circle and outward. If body moving anti-clockwise but with decreasing velocity, then angular acceleration will have direction normal to plane of circle and into it. Angular velocity, angular acceleration are in fact axial vectors. These are axial vectors. There is relation between linear acceleration and angular acceleration. You know here alpha is equal to omega 2 minus omega 1 upon t2 minus t1, or omega 2 v2 upon r minus v1 upon r, because r is the same, because body moves circular path, so radius does not change. So we can write it as 1 upon r into v2 minus v1 upon t2 minus t1. or alpha equal to A upon R, or A equal to R alpha. This is the relation between linear acceleration and angular acceleration. It will be used while studying rotatory motion. Okay, thank you. We'll meet in next video.